This network demonstrates static routing and network address translation in the context of a network that implements router redundancy using Cisco's Hot Standby Routing Protocol, version 1. As we begin working on this network, the end devices are pre-configured and all router interface addressing is pre-configured as well. The objectives of this network exercise are: 1. Configure network address translation, port address translation on the edge router. 2. Add standby configuration to both hot standby routers, R0 and R1. 3. Add static routing. It's important to note that the ISP router will have no visibility beyond the edge router. While we're configuring this network, we'll do the following. 1. We'll look at the routing tables before and after adding in the static routes. 2. We'll use Packet Tracer's simulation mode to view the packet paths between the PCs and server 0 when A, hsrp router 0 is the active router, and B, when hsrp router 1 is the active router. 3. We'll observe preemption in the operation of the hsrp group. And 4. We'll view how network address translation operates on the edge router. 5 summary questions to keep in mind while viewing this video. 1. What default gateway address is configured on the PCs? 2. Is the static route configured on hsrp router 0 the same as the static route configured on hsrp router 1? 3. If network address translation and port address translation were not configured on the edge router, what configuration change would be needed to route responses from the ISP router to the 10.0.0.0/24 local area network address space? And 4. Removal of which static routing statements would result in the ping response destination host unreachable? And 5. What MAC address is in the PC0's ARP cache for the default gateway? And actually, what MAC address is in the ARP cache of each PC for the default gateway? Routers in an hsrp group communicate using the multicast address 224.0.0.2 on UDP port 1985. By default, routers in an hsrp group send hello packets every 3 seconds. Host machines that use an hsrp version 1 group as a default gateway are given the following MAC address in response to the ARP request that is sent out for the default gateway IP address: 000000C 07 AC XX, where XX is the standby group number. Now this is a number, it's an 8-bit value, 4 bits and 4 bits, so its range goes from 0 to 255. And so if this is hexadecimal, the range will go 0 to FF. Now let's configure this network. On the edge router, interface G00 and G01 are going to be IPNAT inside. That's these two interfaces right here. Interface G02 is going to be IPNAT outside, and that's this interface right here. Now also on the edge router, we're going to configure this standard access list 7, and we're going to have it permit the local area network address space. And then we're going to configure the IPNAT inside source to use this list to do the translation so that all addresses that fit this description will be translated to the address that's configured on G02. Overload instructs the edge router to use a unique integer value and attach it to the outgoing IP address to make each packet stream unique. And finally, on the edge router, we're going to configure our static routing. But before we do that, let's look at the routing table, show IP route, and we can see that the edge router only has knowledge of the networks to which it is directly connected. Once we put in these static routing statements, here we have a default route that'll get us out to the ISP, and here we have two static routes that will get us back to the local area network address space. Let's put those in place. And now we'll look at the routing table. Now we can see that we have a static route that has two options, two static routes to get to the internal address space. Therefore, this you'll see automatic equal load balancing. The router will take turns sending packets down each path. We'll see that in the simulator. The other static route that we see is the default route, which takes us out to the ISP. Now let's configure the standby routers. That's these two routers right here. That's the standby group. And notice both have an interface that's connected to the local area network. This is a multiple access network. And they are in the 10.0.0/24 address space. We'll configure R0 using the default priority value of 100. Notice it's not shown here, therefore the default priority will be 100. Show standby. We'll see that its default priority is 100. And right now, it's in speaking right now. It doesn't have another router with which to communicate. But now we'll configure R1, and then we'll see some communication. And this has a priority of 120. They're still speaking. Now we see the state change. For R0, we see it become the active router, but then we'll see that change again once R1 finishes its startup. There. Now R0 goes to standby because it has the standard, or the priority is the default value of 100. And then we'll go look at R1, and it is now the active router. So if we do show standby here, we can see that it is the active router. Now let's look at the routing table in R0 and R1. Here we can see we have the default static route, which takes us to the edge router. 10.0.5.2 for R0 is its next hop address to the edge router. On R1, our next hop address to the edge router is 10.0.5.6. Now if we go from PC0 and we want to get to this server, we're going to go in the simulator and let's see what path the packets take. We have ICMP enabled. Notice that the packet goes to both routers, and only R1 forwards the packet. Now, while we're up here, let's look at the contents of that packet. On the inbound PDU, in this packet, the source IP address is 10.0.0.5. That's PC0. The destination IP address is 209.165.200.10. That's our server. The outbound PDU, the source IP address changes to 209.165.100.2. That's the network address translation doing its work. Now let's go in the edge router and do a show IPNAT translations. And we can see this translation take place. The inside local is the PC 10.0.0.5. The inside global is 209.165.100.2. That's the address of G02 on the edge router. Notice the outside local address is the address of the server, and outside local and outside global are the same. So now let's finish this packet out to the server and back. Now let's see how what path the next ping takes. Out, it will be the same path, but now we'll see equal load balancing send a ping response down the other path from the edge router. Okay, and then again, let's look at our network address translation. We see another instance for this packet that just traversed the network. Go to real-time mode. Now let's see what happens if we look at the web page on server 0 from both of these PCs. Now it's important to note that this number here it's an integer that is unique for each packet stream, and it's not a port number because this is ICMP. ICMP only operates at layers 1, 2, and 3 on the network. So these are not port numbers. Now let's see what happens if we change the R0 to have a higher priority than R1. Remember, this is an interface command. Standby, group 5, priority, we'll make it 140. We see a state change. This router becomes the active router. And if we look at R1, it goes to standby. And here we have show IPNAT translations after accessing the web page from PC0 and PC1. And now we see we have port 80 as the destination port. So this is a socket, an IP address, and the layer 4 value, the service identifier or port number. And here's a source port, 1025. Now for the inside local, these source ports originated from the host machine. Now here in Packet Tracer, the host machines are starting their source port number from 1025 going forward. Now notice here in the port address translation, a different number exists on this first one. This is determined by the router as part of port address translation, as is this number here. Now if we add another PC into this network and do the same thing, we'll see yet another port number be used. Configure the default gateway. Connect it. Fast forward so spanning tree can finish its work. And now we'll go to the web page as well from this PC. And we'll look at network address translation again. And now we see yet another number. It's different. So the source machines here in packet tracer, so they're all using the same source port, but the port address translation is substituting in its own source port identifier to make these conversations unique. That concludes our work on this network. Be sure to know the answers to these 5 summary questions and have fun building this network.